Hello everyone. I hope you all are doing good. This is Lakshmi Narayana, Senior Physics Faculty. Today we're gonna discuss one of the important chapter in physics. I hope you all are guessing the chapter. Okay. So before starting the section, let's wait for a few more seconds to other join the sections and all. If you have any doubts or queries, please comment in the comment section or chat box. Okay, so let's wait for a few seconds to others join the live classes and all. So I think you all are waiting for the section, right? So can you guess that what is the topic we're going to discuss today? Any guess? Any guess? Hmm? Okay, so without any delay, we will start our live section. Clear? Yeah. Today topic is woman high and the colorful world. I hope you all are waiting for the topic to understand better in this chapter of woman high and a colorful world. So we have some basics. What is woman high and how the world is beautiful? So can we say without an eye, can we say the world is beautiful? Is it possible to say the world is beautiful? If you want to say how the beautiful means, what is the required part in the human being? What is the required part in the human being? Eye. Okay, so today we're gonna discussing with that woman high and colorful world. Okay, yeah. Now see what are the topics we're gonna discuss in the chapter of woman high. See, introduction, introduction of the chapter, introduction of the chapter. Okay, so there is no introduction about the human high especially because in daily life we are experiencing with that human high. Without a eye we cannot see what it is present in front of you. Okay, if you want to say that anything is beautiful or everything is beautiful, what is the required part of the human being? Eye. Okay, so that I only we are going to discuss in today's section. Woman high, woman high, and power of accommodation. Woman high is that, and next power of accommodation, and then after we will discuss about the defects of vision and their correction, and refraction of light through a prism, dispersion of white light by a glass prism. Okay, atmospheric refraction and scattering of light. These are the topics we're gonna discuss in today live section. Okay, so can we go to the topic? Yes. See, woman eye. So woman eye is like a camera. So how a camera is work? If you like anything, what you will do? We will capture that one, right? We will place, we will capture that one and we will use it for memories. Okay. So here I also do the same thing. Here I also do the same thing. What it is doing, whatever the things or whatever the surroundings you are seeing, everything it captured. Who will capture? Nose, a mouth, or ear? What? Who will capture? I will capture. So I act like a camera. I act like a camera. How camera is working? Here, woman I also working in the same way. Capture which are present around us. Okay, capturing that from our surroundings and converting into powerful signals. Okay, converting into powerful signals. Why it has to convert into a powerful signals? Because which we are gonna see by the eye. Okay, what will, for example, I'm seeing a fan here. How I know it is a fan? If I'm seeing a book, how I know it is a book? If I'm watching a TV, how I know it is a TV? Who will say this all the things? Because the eye is the take the capture all the images or all the things it transfer to the nerve, optic nerve. Okay, This optic nerve is connected to the brain, then we can identify what is this and what is that. Okay, so what it will do, it turns into a powerful signals. Powerful signals interpret as a images. Clear? Clear? Next, see, these are the terms we're gonna discuss in the parts of eye. Okay, what other terms are there? How many? Approximately 8 or 9 terms are there. You have to remember these terms particularly. Okay, so we are using the eye in everyday life. Can we do any work without presence of eye? It's not possible. So that eye is helping a lot in a daily life. Okay, to see a movie, to play anything, to play games, to play sports, or to do any work, what is required? Eye. So if the eye is working this much in importance in your lives, you should know some points regarding the eye, right? So see, what are the terminology we are using here? Crystalline lens. Okay, what are the terms we are using? Crystalline lens, crystalline lens. Okay, so initially what we discussed, eye act like a camera. In camera also lens there na. Camera also lens is there, right? So here also lens is present. What we call that lens? Crystalline lens. Okay, crystalline lens. How the lens working in camera, in eye also, this crystalline lens do the same thing. Okay, see, crystalline lens, how it will be, crystalline lens. This is the crystalline lens. What it do? It pass the light through it. It passes the light through it and place it on retina. It plays on the retina. Remember the name? Retina plays a key important role in parts of eye. Why? Because here retina is there. What is the retina functioning here? It act like a screen. It act like a screen. Okay, if you're going to the movie, where you will see the images and pictures, we all see the images and pictures on the screen, right? So here also, okay, where we will see that all the images and all on the retina. So that's why retina is acting like a screen. Retina, if you want seeing anything or any object you are seeing, means how can you say that object is particularly this is fan or this is book or this is the table? How can we say? The image capture on the retina. The retina is act like a screen. Okay, next, people. So what is the people here? What is the people? See, look at that. Where is the people? It's controlling that dimension of the eye. It's controlling that dimension of the eye. Whenever it required, it will be enlarged. Okay, next, cornea. What is cornea? It's a front part. Look at the diagram very briefly. Look at that. This is the front part, right? This is the front part, right? So this front part, what we call it is a cornea. What is the functioning of cornea? It acts like a thin membrane in part of an eye. Okay. Next, optic nerve. Optic nerve. What the optic nerve it does? Optic nerve. Okay. See, the images are captured on the retina. This information is passes to the optic nerve. With the help of the optic nerve, again it transfer to the brain. Then it capture which object we are seeing. So this optic nerve helps us that transforming information. If you are transferring one place to another place, any information, what we will use? Mobile we will use. Okay, transferring the information. If transporting anything, what we'll use? Vehicle we will use. So here optic nerve is act like a transforming between retina to the brain. So then brain capture what it is that. Okay, next, vitreous humor. Vitreous humor, in the part of an eye, maximum amount, the maximum amount of liquid is vitreous humor only. So maximum amount of liquid is what? Vitreous humor only. What it will do, that vitreous humor? What that vitreous humor do? To give a shape of the eye. What it do? Give a shape of the eye. What is the shape of the eye? Mostly spherical. Mostly spherical. So if you want to get the spherical, which is the important one is that here vitreous humor. Next, coming to one more humor, aqueous humor. Where it is present? The aqueous humor is present in between. See, in between cornea and as well as lens. Where is the aqueous humor present? It is in between cornea and lens. Here it is present. Cornea and lens it is present. Okay. So what it will do? It protecting that. It protecting that. Next, what is iris? What is iris? So iris is also one of the part of an eye. Okay. So look at here once again. We recapitulate everything. Retina. What is retina? It act like a screen. It is acting like a screen. Cornea. What is cornea? What is cornea? It act like a thin membrane. So which parts I'm underlining? Remember that points. Okay. If you want to write in a notebook, write down these points only. Okay, na? Retina means what? It act like a screen. If you're seeing a picture or any object or anything, where it takes place? On the screen. On the screen it takes place. Next, cornea. So cornea is what? It is a front part of an eye. It is the front part of an eye, and it how it will be? It like a thin membrane. It like a thin membrane. Next, coming to the third one, people. So what the people needs to regulates and control the amount of light entering into eye. What it do? Regulates, controlling the amount of light entering into the eye. For example, the maximum amount of light is placing on my, how is my reaction? Can I see which object is present in front of me? Is it possible? If anybody is in front of me, a car is there. Okay, they started headlights. Is it possible to see that amount of light? How my eyes will be? Very dim, right? I cannot see that. How the eyes will be? It comes to very small, like comes to that very small. How it comes that amount of light? Who will controlling this? All the people will control. Okay, if any small amount of light also, how my eyes will be? It will be very big. Okay, so it controls the amount of light entering into that. How much amount of light entering? Who will control? People will control. Okay, next one, ciliary muscles. Okay, what it is that? Ciliary muscle. So ciliary muscle means what it will do? It gives the shape of the lens. It gives the shape of the lens. See, if you take a lens, how the lens will be? The lens will be like this, right? For an example, the lens will be like this. Sometimes the lens will be elongated. Sometimes the lens will be compressed. So who will do these all things? It will do by the ciliary muscles. So what it does the ciliary muscle? What is the functioning of the ciliary muscle? Changing the shape of the lens. Remember that. Changing the shape of the lens. Okay. If the lens is like this, it will be elongated like this in a curved part. Who will do? Huh? Who will do? Ciliary muscles will do. Okay. If want to compress it, who will do? Ciliary muscles do. Why it has to be do like this, Thunder? Huh? Why it has to be changing the shape of the lens? If the lens changes means what happened? Adjusting the focal length also. Focal length also changes now. If you take lens like this and if you take the shape of the lens like this, both will have same focus? No. Both will have same focus? No. Both are not having same focus. Then who will controlling these ciliary muscles? Okay, ciliary muscles will do. Next, iris. So what is the iris? The colored part of the eye. What it do? That controls the diameter and size of the pupil. The pupil is there, na? Right? Amount of light. How much amount of light is entering? Who will do? People. So what the functioning of iris here? The color part, which is the color part is there. If you see in front of the mirror, okay, sometimes we will see blue, right? And sometimes we will see that brown color. So that colored part of the eye, okay, that what it do, that control the diameter and size of the pupil. What the people do, sometimes increasing, sometimes decreasing, very small. So that controlling who will do, iris will do. And next one, crystalline lens. So crystalline lens we already discussed it. It is a transparent material, okay, it is a transparent material. Next, optic nerve. That optic nerve also what it is do, transmit that information to the brain. Who will transmit to the brain? Optical nerve, it transfer the information. Previously we discussed it act like a vehicle. Okay. Next, aqueous humor, where it is present in between cornea and lens. Next, one more humor is what? One more humor is what? Vitreous humor. Okay. So the maximum amount of liquid in the eye is that vitreous humor only, where it is takes place between lens and the retina. See, vitreous humor where it is present, it is also present in between lens and cornea. Cornea is what? It's the first part. Cornea is what? It is the first part of an eye. Okay. From in between cornea and lens, which liquid is present? Aqueous humor it is present. In between lens and retina, see, if you take this is the lens, it's a midpoint, it's a mid part. Okay, before the lens, cornea is present. Before the lens, cornea is present. After the lens, what it is present? Retina is present. Okay, retina is present. So in between cornea and lens, which liquid is present? Which liquid is present? Aqueous humor is present. Aqueous humor is present. Okay, in between lens and retina, there also one more humor is present. What is that humor? Vitreous humor. What is the liquid is present? Vitreous humor. Okay, remember, cornea lens, aqueous humor, Cl, in between Cl, A is present, L or vitreous is present. Okay, next, so few more important things we're gonna discuss in this slide is that next, power of accommodation. Here, which one we give accommodation? So general meaning of accommodation we know, right? Someone will came, your relatives will came. Okay, not someone. Someone we will not give accommodation. Okay, if going somebody is outside, we will give accommodation to them. No, right? If you give accommodation, that's it. So here accommodation means what? Giving shelter. To whom you are giving shelter here? To whom you are giving here? Who is giving accommodation here? I is giving accommodation to who? Why it is giving accommodation? Why it is giving accommodation? For which one it is giving accommodation? You should know about that. Okay, accommodation is nothing but to give a shelter. To give a shelter, right? To give a shelter. So see here, the ability of the islands, the ability of islands. Okay, what ability it has? Adjusting its focal length. Okay, what it is that? Adjusting focal length. See, previously we discussed in previous slide, if you're having these two lens, okay, with the different diameters having same focal length, no, the focal length is changes. Okay, why the focal length is changes? Because lens changes. If lens changes, automatically focal length also changes. Clear? So eye lens is what it is doing? Ability. What ability it is? It has adjusting the focal length. Why it has to adjust the focal length? Why it has to adjusting the focal length? To form an image. To form an image. Where on the retina. Where on the retina. So to form the image, to form an image on the retina, this focal length are adjusting. Okay, so this adjusting is called as that accommodation. Remember, accommodation is nothing but shelter. Shelter. For which one it is giving? To the image. To the image. So where the image takes place? On the retina. For adjusting that image on the retina, who is working on it? Lens are working. What type of work it is? What type of work is that? Adjusting that focal length. Adjusting the focal length. It has that ability. So this procedure we call as that accommodation. Clear? Next, to see an object comfortably and distinctly, you must hold it able to about 25 centimeter from the eyes. 25 centimeter from the eyes. So to see an object comfortably, I am taking an object here. I am taking an object. Okay, I am taking a book. If I want to read the book, where it will be, for suppose here it is, a few words are there. If I want to read that, where I have to place it, very clear. Very clear. I will place in print like this. Yeah? Is it possible? I can read. Now, if you want to read it, how it will be? I have to see be very big. It has to be very big. Okay, so very big. I cannot see. So that what is the distance I can see without any disturbances and comfortably. Okay, for comfortably, what is the distance? I have to place this book at least 25 centimeter from the eye. Okay, 25 centimeter from the eye. So that much distance. Okay, next, the minimum distance at which object can see mostly without strain is called least distinction of vision. What is the least distance of vision, ma? Least distance of vision. What what is that? The minimum distance at which object can see mostly without strain. Without strain. See, if the object is very coming nearer, means what happened? We have to enlarge our eye, right? See, the pen is coming towards me. How it will be enlarging? Okay, without a strain. Okay, what is the distance? See, if I will keep it here, what happened? I'm feeling strain. Okay, I will keep some distance. I will keep some distance. So at what distance there is no strain and comfortably I can see that. That is called least distance of vision. For example, the eye is here. For example, the eye is here. Okay, the object is here. Okay, I'm taking an object here. The object is here. See the distance between here. If it is strain, it's not a distance vision. Okay, I'm moving the object away from the eye. Away from the eye. For example, x centimeter I travel the object. So at this x centimeter I am feel comfort. At x centimeter I feel comfort. So this x what we call least distinction of vision. Clear? Least distinction of vision means where you can see the objects or things comfortably. For a normal human being, what is that, ma? What is the range? Between 25 centimeter to infinity. So, normal being. Okay, I can see from 25 to infinity. This is for only normal human beings. Okay, if you think you are a normal human being, you have to check whether where you can see the object between 25 centimeter or beyond 25 centimeter or 25 centimeter to infinity. Okay, next. Next, so again, so what are the terms we are using? Crystalline lens. It is act like a transparent. We will finish it very quickly. Just remember the names. Transparent. Aqueous humor. Aqueous humor, where it is present in between C and L. Lens C and L. And similarly, vitreous humor, where it is present between lens and retina. Between lens and retina, L and R, C and L. Okay, people maximum amount of light. Iris controlling the people. Cornea membrane, a thin membrane. Okay, thin membrane. Next, retina screen. Optic nerve passes the information to whom? To whom it passes the information? To the brain it passes. And ciliary muscles also. Ciliary muscles, what it do? What it do? It adjusts the focal length to form the image on the retina. Okay, remember the terms? Crystalline lens, transparent material. Aqueous humor between C and L. Vitreous humor between L and R. Cornea, it acts like a thin membrane. Pupil, amount of light. If you are seeing that more amount of light, Okay, who will do work here? People. Iris controlling that people. Next, ciliary image is suggesting that retina act like a screen. Optical nerve passes the information from one position to another position. Clear? Next, define the what you want to define here. What you want to define the power of accommodation. Define the power of accommodation. Okay. Anybody from the chat box? What is the power of accommodation? Power of accommodation. Accommodation means giving shelter. Giving shelter. Accommodation means giving a shelter. Power of accommodation. Accommodation is nothing but giving a shelter. To whom you giving shelter? For image. Okay. Remember now, we already discussed. I'm giving a keywords to remember along. Okay. Accommodation, giving a shelter. Okay. Next topic, defects of vision. What defects are there in a parts of eye? What defects are there? So can we every person can see least distance? Every person can see far distance? Is it possible to everybody in a human life? Is it possible? No. We are seeing some people using spectacles, specs. Why? Why they are using specs? Is there for stylish? Is there for stylish? No. Behind that there is some reason. Okay. So in that human eye, we have three defects of vision. What are they? What are they? Myopia, hypermetropia, and presbyopia. What are the defects of vision? Three defects of vision. Okay. Three defects of vision. What are they? Myopia, hypermetropia, presbyopia. Okay. If you want to remember these three, just write HP company at Miapur. HP at Miapur. Okay. HP company at Miapur. Okay. HP company at Miapur. H hypermetropia. P presbyopia. M myopia. Clear? Next. See, what is myopia? What is myopia? What is the another name of myopia? Nearsightedness. Nearsightedness. Myopia. How the term will be? Myopia. How the term will be? Very short. How the term will be? Very short compared to hypermetropia. Myopia, what we call? It is also known as nearsightedness. Okay. Myopia, how the term will be? Short. Myopia, how it will be? Short. That means myopia, a person can see near objects. So if you want to remember, myopia means comparing the myopia and hypermetropia. How the sentences are? Myopia is small, hypermetropia is large. So myopia short. So the short distances person able to see. And what about the far distances? Cannot see. Remember, myopia, how the term? Short. Myopia, how the term? Short only. You can see short distances. I am taking a book. For example, I am the person having a defect of myopic eye. What I can do? I can see short distances only. Far distances, I cannot see. I will take some other help. What is the object present? Okay. What is the object is present? So, myopia means, how can you remember? Sentence is what? The word is short. The word is short. And the person defect also you can remember, you can see short distances. Near objects only you can see. Long objects cannot see. Remember, how you remember? Simply, myopia means short. That means you can see short distances. Near distances only you can able to see. Okay. So, why this reason is happened? Why the person cannot able to see? Okay, why person cannot able to see the distance objects? What is the reason behind of that? So see, look at the reasons. What reasons are there? Excessive curvature of the islands. Excessive curvature. If you take islands, how the curvature will be? how the curvature will be? Excessive curvature. If the curvature is more big, the curvature is more big, you cannot see the long distances. Okay, and what is the one more reason behind of this? Elongation of the eyeball. Okay, the ball dimensions are increases. These are the two reasons for defect of myopia. Okay, what is myopia? How the name? Short. So see, short distances. See that short distances, long distances cannot see. Why this is? Because of elongation of the eyeball and excess curvature of the eyelids. Remember it. Okay. So how can you correct this type of persons? Okay, I am having a myopic eye. Can I continue for long time? I will choose a remedy, right? Okay, so what is the remedy is for that? Okay, what is that defect? How can you correct the defect? Here, which lens we have to use? Which lens we have to use? Concave lens. Which lens we have to use? Concave lens are the suitable for if any person is having a defect of myopic eye. Clear? Look at the diagram to understand better. See where the light rays, which eye? Myopia. Which eye? Which eye? Myopic eye. Myopic eye means how the name myopia. It means you can see short distances only. Where is the object in the diagram? How the light rays? Parallelly. It means it started at infinity. Can able to see? No. What is the reason? What is the reason? Excess of lens. Excess of lens. Both are L only. Both are E only. The two reasons are E. Excess of lens. And what is one more E? Excess of eyeball. Elongation of the eyeball. So, infinity, where it takes place? Where it is takes place? In front. Where it is takes place? In front of the, okay, in front of the retina. Okay, in front of the retina. So retina is what? It is acting like a screen. It is acting like a screen. Image capture on the screen, then only it shows what type of image, and the retina passes the information to optic nerve gives to the brain, right? So here retina is screen. So where it is placed? In front of the screen only. The object is in front of the screen. Is it possible to identify which object is present? No. If you are going for watch a movie, where you will see movie, where you will see on a screen, right? If it is in front of, can you able to see? No. So here also, where is the image takes place? In front of the retina. Remember, in front. Myopic means in front of the retina. Retina is what? Screen. If takes place on the screen only, it captures. In front of the retina? No. Okay. So infinite distance it started the object. After refraction, where is the image takes place? In front of the retina. In front of the retina. That's why the person cannot able to see a far objects. Okay. Then how can we correct it? How can we correct it? Which lens we prefer? Concave lens we prefer to correcting the defect of myopic eye. See, whenever we using a concave lens, where the image capture ma? Where the image capture? Exactly on the retina. Exactly on the retina. It means exactly on the screen. Then the person identify which object far away from. Clear? Next. Next defects of vision. Hypermetropia. How the term will be? How the term will be hypermetropia? Is very large. Okay, what is another name of hypermetropia? Farsightedness. What is another name for hypermetropia? Farsightedness. That means name. How the hypermetropia? How the name will be? How the name will be? Long. Myopia short. Hypermetropia long. That means can see. Can see anybody from the comment section? Can see? Yes. Can see long distances. Cannot see near objects. Both are opposite. Myopia, short sentence. Can see short distances only. Hypermetropia. Long name. Can see long distances. Cannot see short distances. Clear? Compare myopia and hypermetropia. Okay. Compare myopia and hypermetropia. Physics is not come easily. Compare. Okay. Have you heard the dialogue? Have you heard the dialogue? Compare. Okay. So physics also you need to compare myopia and hypermetropia. Okay. What is the reason behind of hypermetropia? There the elongation of the lens, excess of curvature of the lens. Here, here the focal length of the eye lens is too long. Okay. Focal length of the eye lens. See, I am taking a lens here. Okay. How the object how the lens will be, where it takes place, focal length means what ma, between pole or optical center to f, whatever the distance is there from optical center to f, we call it is that focal length. So how the focal length, how the focal length how the focal length, the focal length is very long. See, actually if the image is focal length is takes place here, means what happened, the person is having hypermetropia defect, where the image where the light rays will meet elongated. See, actually it is made at this point, means where it is meeting a long distances, the focal length will be long, focal length is long, focal length is long. This is one of the reason. And next one is that eyeball becomes too small. There eyeball becomes very large. Here eyeball becomes lens very small. Okay, don't confuse. Myopia, if you know myopia, hypermetropia is very easy because quite opposite. Quite opposite. I am repeating again. Myopia name short, hypermetropia name big. Short, you can see short distances. Hypermetropia long, you can see long distances. Here no long distance, here no short distance, here concave, here convex. Here what is the reason? Excess curvature. Here curvature is less, here curvature is less, here eyeball is elongated, here eyeball is too small. Quite opposite. Okay, myopia you know na, myopia you know na, compare with hypermetropia, then it will be easy. Okay, which lens we use? There concave, here convex lens. Okay, look at the diagram. Look at the diagram. You can see where the image is takes place, where the focus is there. Where is the focus? Retina. Behind the retina. Behind the retina. One is in front of the retina, and the second one is that behind the retina. See, exactly on the retina, then only we can identify which object or which image is present. Okay, so it's not on the retina, means how can we identify? It is behind the retina. That's why the person having hypermetropia cannot see the distances very clear. Then which lens we prefer? Convex lens we prefer. By using convex lens, what happened? Exactly on the retina. Okay, so remember the keyword. If it is takes place on the retina or not, we have to check it is in front of the retina. In front of the retina, myopia. Behind the retina, hypermetropia. So the key term is retina only. Key term is retina. Key term is retina. Okay. Retina. Retina is a boundary. Just like retina is a boundary. In front of the retina. In front of the retina. What is that? Myopia. In front of the retina. Myopia. Behind the retina. Hypermetropia. Hypermetropia. Okay. Retina is the keyword. Behind, in front of the retina, myopia. Behind the retina, hypermetropia. Retina is a like screen. Okay. Just like boundary. If I am playing cricket. Okay. If I want to hit big six, hypermetropia. Behind the retina. Okay. I am taking singles. 2 or small score means myopia. Okay. Which lens we use for hypermetropia? Convex lens. Okay. For myopia, concave lens. Clear? Clear? Yes. We go for next slide. Next, see here, for better understanding, we take in a help of realistic example here. Okay, see, normal vision, normal vision, where it takes place on the retina, on the retina, on the screen only, on the screen only. Hypermetropia, where it is behind the retina, hypermetropia behind the retina, myopia in front of the retina, in front of the retina. So which lens we used for correcting of hypermetropia? Convex lens, convex lens, or for myopia, concave lens. Clear? Next, and we have third also, third defect also, presbyopia. What is the third defect? It's presbyopia. Okay, this defect mostly takes place on the aged people. Why it is takes place mostly on the aged people? Because of gradual loss of the eye, ability of the focus. Okay, gradual loss of the eyes, gradual loss of your eyes. Presbyopia takes place on only on aging people who are aged. Sometimes they will came, my eyes cannot see. Okay, okay, parent discussing with the child, my eyes cannot able to see distances and all. Why it is possible? Because of it loss of eye. How it takes place? Loss of eye because of aging. Okay, so how it will be gradual decreasing the ciliary muscles. If you compare the young person and old person with the muscle power, the young person having great muscle power. Okay, not only the eye, even that body also, it's supposed to do much work compared to the old people, right? They can lift the benches, they can lift the objects easily, they can do much work better than the old people. I compare it to the coming to the old people, what happened? Their muscle power is decreases. Yes or no? The muscle power is decreases. Because of that reason, they cannot lift the object, they cannot. Even coming to the eye also, the muscle power is decreasing. Because of that reason, diminishing the flexibility of the eyelids. Okay, so if any person is having defects of presbyopia, we have to, that means presbyopia nothing but they suffered with both myopia and hypermetropia. In these cases, to correct the person having a presbyopia defect of eye, what is the lens we will use? Bifocal lenses are we will use. Bifocal, because having myopia is there, hypermetropia is there. So combine the two lenses, concave, convex, combine two lenses bifocal lens we use. Clear? Next, see, a person is unable to see objects closer than 1 meter. The person unable to see closer than 1 meter. 1 meter means 100 centimeter. This 100 centimeter unable to see, cannot see this 100 meter, less than 100 meters, cannot see. Guess and tell me the answer. Okay, less than 100 meters, less than 100 meters. You know the answer? Write in the comment section. If you know the answer, write the comment section. Okay, can we go for next one? Okay, and mention that which type of lens also, because if you know the defect, you have to know that which lens you are using also, right? If doctor knows that what problem you have, then what solution also you know, right? Yes or no? You are saying that, sir, your stomach problem is there, the medicine you will get only for stomach only. Okay, you didn't say nothing and are standing like this means, what is that? Huh? So doctor know what type of medicine has to give, right? If you know that which defect is that, you have to correct the defect. You know which lens you are using na? Comment the answer, okay, in chat box. Next, explain myopia. Explain myopia. Now only we discuss myopia. How the name? How the name? Now how the name? Short. I think you all are know the answer. Myopia, short, right? What are the defects? Two causes, reason, two reasons. What is the name of the chapter? I name. If person is myopia, if the person is myopia, having two reasons, E. Guess the answer and write. What are that? Double E. Okay, not triple E. In the chapter of eye, we have defects of vision, myopia. In myopia, two reasons are there. Write the two reasons. Okay. From the comment section also, you have to give an answer. Okay. Yes. Next. So I hope you all understand up to this topic. Okay. Let's have a 5 minutes break. Then after, with the same energetic level, we will continue the section. Okay. Have a break. Yeah, welcome back again. I hope you finish your break. Okay, so you enjoy the section. Similarly, the second section also we will go like this only with the energetic way for better understanding. If you have any queries, you may ask your queries on the comment section or a chat box. Okay, so without any delay, can we start our section? Yeah. Next, refraction of light through a prism. Refraction of light through a prism. So this is the topic we're gonna discuss now. If you take a prism, you all know about a basic idea of a prism, right? Okay, so in that, if you take a parallel refracting surfaces means parallel. So if I'm taking a parallel rays, what is the angle in between them? Anybody from the comment section or live? If you take a parallel light rays, what is the angle in between them? What is the angle? The angle is 0. The angle is 0. For parallel surfaces also the angle is 0. So what type of surfaces I am taking? A glass slab I am taking. How the glass slab will be? Parallel surfaces are there. Okay. So this is a parallel with the second one. Two parallel surfaces are there. Okay. The emergent ray is parallel to the incident ray. For example, if I passes a light ray through the glass slab, okay, I am taking a light ray. Okay, I am taking a glass slab. Through the glass slab, I am passing one light ray. So which ray it is that? Incident ray. Which ray it is that? Incident ray. So how you know it is incident ray? How you know? Because the direction is what? Towards the surface. So if the direction is towards the surface, the ray is incident ray. Okay. Next, you have to observe one more key point here. See, first where the light is in air, for example, I am taking in air. And second, where it is entering. Second, it is entering in glass. So two mediums are there. Air is one medium, glass is another medium. If two mediums, the light travel. What happened? Anybody from the comment section? Anybody? If light travels in two different mediums, what happened? Yes. What is that? Refraction. Very good. Very good. What happened, ma? When light travels in two different mediums, refraction takes place. So here also two different mediums light travel. Here also takes place the refraction. So here it is a point of incident. Okay. So this is imagine reflected ray and this is the normal. Okay. Reflected ray. And here also normal. What happened? Where to where light travel? Air, glass. So air is a rarer medium. Air is a rarer medium. Glass is a denser medium. Rarer medium, denser medium. Two mediums are there. So what is mean by rarer and what is mean by denser means rarer. Light travels fast in which medium that we call rarer medium. Light travels slow in which medium that is called denser medium. Okay, rarer medium means light fast, denser medium means light slow. So whenever light traveling from rarer to denser, okay, when light traveling from rarer to denser, remember this point. Okay, this point will help you in chapter of light in topic of refraction. Okay, light travel from rarer to denser. It away from the normal. The light ray is that away from the normal. See, rarer to denser. Actual light ray like this. Okay, this is the actual direction of light ray without a glass slab. But when we place a glass slab, what happened? This is the actual light ray. This is the normal. Okay, it act away from the normal. It act away from the normal. See, away from the normal, away from the normal, when rarer to denser. Okay, and again what happened? And again what happened? This is the actual direction of light ray, right? This is the refracted. This is the actual direction. See, this is the refracted ray. Okay, and see again what happened? Again denser. Again light travel from, again see, first to rarer to denser it travel. Again light is emerging out, right? Denser to, again this place is that, again this place is that, again this place is that air only. So again denser to air it is coming. So whenever denser to air it is coming, that how the two rays will be? When denser to rarer, when denser to rarer, it is towards the normal. When denser to rarer, towards the normal. So incident ray and emergent ray, incident ray and emergent ray, how these two rays will be? Parallel. How these two rays will be? Parallel. When light rays travel from parallel surfaces, what happened? After after refraction, incident ray and emergent ray both are parallel. Incident, if the incident ray is like this, emergent ray is like this, so both are parallel. Okay, next, coming to the prism. Prism has two triangular bases. You already know. If you see the triangular prism, how many bases it has? Two bases it has. Okay, and three rectangular lateral surfaces. Okay, next, the angle between, the angle between two lateral faces is called angle of the prism. What is the angle of prism? What is the angle of prism? The angle between two lateral faces. Okay, look at the diagram. This is the one lateral face. This is the another lateral face. So the angle between these two, what we call? Angle of the prism. What is this? Angle of the prism. Angle of the prism. Okay. See, through the prism, how the refraction takes place. See here, what is PE? What is PE? PE is incident ray. Look at the direction towards the surface. Okay, towards the surface. Light is towards the surface. Look at the direction. Towards surface, incident ray. And here, what is the point of incident? The light reflected and as well as refracted also. This is medium 1 and here it is medium 2. When light strikes at that point, take a normal. This is a normal. The angle takes place between incident ray and normal. What we call? Angle of incident. Okay, angle of incident is I. Okay, next, refracted ray. Which is the refracted ray? P is incident ray and EF is what? Refracted ray. This is the bending ray. Bending ray. Okay, bending light ray is a refracted ray. And which are coming out through the prism. Which light ray is coming? Look at the direction from F to S. Fs. What? Coming out of the prism. That is called emergent ray. Okay, emergent ray, incident ray, reflected ray, normal, emergent ray. Four rays are there. Okay, incident ray is what? P, refracted ray, EF, Fs, emergent ray, and normal. Next, angle of the prism. Two lateral surfaces, angle of the prism. Angle of incident, incident ray, normal. Angle of refraction, refracted ray and normal. Okay, this is a refracted ray and normal is extended like this. The angle between refracted ray and normal we called angle of reflection. Angle of refraction. Next, emergent angle. Emergent angle means emergent ray is there. Emergent ray which is coming out of the prism. Okay, emergent ray. So the angle between emergent ray and normal. Here also one more normal is there. Angle between these two is called emergent angle. And one more angle also there. Angle of deviation. Angle of deviation. So angle of deviation is nothing but, for example, if I'm explaining the class, okay, or if you are in a class, you can focus the entire class Are you focused the entire class? No, sometimes your friend call you, look at there and look at there, huh? Or look at that what type of dress they are having. Okay, look that person. Okay, and look what happening. We will divert in a class, right? So here also, the actually light ray is what, ma? The PE is incident ray. Okay, this is the actual direction of light ray. Okay, this is the actual direction of light ray. How you have to focus in class? You have to focus actually, but your friends are diverting you, right? So this is the actual direction. Okay, this is the actual direction. But whenever through the prism, whenever it passes through the prism, what happened? It diverted. Okay, so the angle takes place between actual light ray. The angle takes place between actual. This is the actual direction of the light ray. Okay, actual light ray and diverted light ray is called, the angle takes place between the two, we call as the angle of deviation. Okay, simply how many angles are there? Incident angle, reflection angle, refraction angle, emergent angle, deviation angle. Clear? Next, draw ray diagram of refraction of light through a glass prism. Okay, now you see in the diagram now. What diagram is required here? Ray diagram of refraction of light through a glass prism. Okay, mark the angle of incident I in the diagram P. Like that, you have to draw that. Okay, angle of refraction, angle of incident is what? The angle between incident ray and normal. Angle of refraction, refracted ray and normal. And angle of deviation, actual light ray, actual light ray, actual light ray, and actual light ray and deviated ray. The angle between actual light ray and deviated ray. Actual light ray, excuse me, actual light ray and deviated ray. Okay, angle of deviation. Next, angle of deviation completed na. If they ask angle of emergence also, emergent ray. If they ask emergent angle also, emergent ray and normal. Okay, incident ray normal, incident angle, refracted ray normal, refraction angle, emergent ray normal, emergent angle, actual light ray, deviation angle. Okay, clear? If you see the diagram, you can understand these things. Okay, now next, dispersion, dispersion of white light by a glass prism. Okay, okay, dispersion, disperse. If you class completed, if your class is completed or school is completed, finally what they will say? Disperse. What is the meaning of disperse? I think you know this dispersion better than me. Okay, because you all are waiting for every class when they will say dispersion, when the class will over, when the school will over. As a child, you all are think, right, when they will say dispersion, or if you're standing in a line. Okay, or if the any meeting is there, if you're standing means, we will always think that when dispersion will come, at what time it will come. So dispersion, you know the what better, right? So here also dispersion takes place. Here also dispersion takes place. By whom the dispersion takes place, we have to see. Okay, so the prism is there. Okay, prism is there. This prism, what it is doing? Splitting. The prism, what it is doing? The prism, what it is doing? Splitting. Split, separation, splitting. Okay, in classroom also we are separating, toppers we separate, average students we separate, slow learners we separate. So here what happened? Light passes through prism. Okay, I am taking a prism, a light is passing through the prism. What happened? This, which light we are passing? White light. Okay, after passing, what happened? You will get band of colors, band of colors. It means combination. It means combination of colors. Sometimes in class hours also, if you take a scale, we will see like this through the scale, right? Like this, we will through the scale we will see some colors under. So which color will be like that? Okay, after passing through the glass, it will be band of colors. So this band of the color components, what we call spectrum. Okay, spectrum means combination of colors is known as spectrum. Okay, combination of colors we call as spectrum. How the spectrums comes? By the how the spectrum comes? By the single white light. Okay, the single white light passes through the prism. Through this prism you will get band of colors. That band of colors we call as that spectrum. Spectrum is nothing but combination. Okay, so this separation, this separation, okay, this separation, the splitting of light into its component colors, the process of splitting we called dispersion. Okay, after prayer over, where we will go? All are going to one classroom? No. Okay, for each section or each class, students will be separated into separate sections, right? So here also splitting, the process of splitting, what we call dispersion. Okay, so different colors of light went through different angles. All students are not going to one room. Na? Here also different students will go to different sections and different classrooms. Here different colors of light through different angles. Okay, it depends upon the incident ray, how the incident ray will be. Okay, if the incident ray is like this, then the dispersion will be separate. If the incident ray is like this, the dispersion will be separate. Okay, if the incident ray is like this, the dispersion will be separate. Okay, and coming to the next point, remember the point, red light bends least. Red lights bends least, and which one will be high? Violet is the most bending of light. Okay, why violet is bending? Why red light is very less? Huh? Anybody can guess the answer? Why red light is bending least? Why violet is bending more? Anybody? Both are coming from white light only, na? Red light also coming from white light only. Violet also coming from white light only. But why having bending difference in these two? Anybody from the comment section or hmm? Anybody? It depends upon their wavelength. Okay, it depends upon their wavelength. Okay, next, look at that single white light, single white light, single white light we taken. Okay, single white light we taken, single white light. So this single white light splitting into seven colors. Look at there. What are the colors? Violet, indigo, blue, green, yellow, orange, red. Okay, red, red. This is red, not pink. Okay, red. So splitting of seven colors. Splitting, what we call that procedure of split. If it is split means what we call dispersion. So what happened here? A single white light, a single white light, a single white light separated into seven colors. Okay, that means splitted na. The process of splitting, what we call, the process of splitting, what we call dispersion. The process of splitting, what we call, the process of split one color into seven colors, what we call it is that it's called dispersion. Clear? Splitting into seven colors. Okay, even you also, if no one is there, your behavior is like one, like, right? In front of your parents, in parent teacher meeting, your behavior is one. In front of the teacher, your behavior is one. Okay, in front of your friends, your behavior is one. In a one person, how the variations will be? Okay, in a one person, how the variation will be? If no one is there, you will chill, you enjoy the class. Okay, with your friends, they know your reality. Okay, in presence of the teachers, your behavior is one. Okay, so many variations are there in human being. How the one person, how many variations are there? Okay, so like that, a single white light, it split into the number of colors. That is called as the process of dispersion. How many are there? It forms the Wibger. Okay, next, recombination of light. Recombination of light. So initially we discussed the one light ray, a single light ray separated into seven, like Wibger. Okay, one light ray. What is that one white light? One light ray, white light only. So this one light ray separated into seven colors, it forms the Wibger. And here what it is doing? What it is doing? Recombination of light. Okay, so that means these seven colors again form into a single white light. Again, these seven colors form into a single white light. It's very interesting, right? First, one white light ray passing through the prism, it's divided into seven, split into seven, and again that seven light ray colors, okay, passing through the prism, again white light. This is physics, guys. Okay, many miracles will happen. Okay, so you have to see how it will take place. See here, a white light we taken. Okay, a single white light rate we taken. Single white light we taken. Where it is takes place on the prism. On the prism, what happened? Dispersion. Dispersion. Single. See, single is divided into seven. And again 7 passing through the second prism, and again you will get white light ray. Again you will get white light ray. Any difference you will see? First passing through the prism, that prism split into 7 colors. Again that 7 colors passing through the prism, again you will get white light. See, we have to get white light passing through the 7. If you want to get it back, 7 to 1 means 7 to 1 to 7 is straight forward. Let us think it is straight forward. 1 to 7 is straight forward. 7 to 1, invert na, reverse na. So 7 to 1 is what? Reverse. So that means you have to place the prism. The second prism you have to place it is that inverted. You have to place that inverted. So by the placing of inverted prism, what happened? Again this 7. See, if you place like this prism, separated. If you place this in opposite direction, inverted means what happened? Combined. If you place this inverted, combined, and form a single white light. Here combined white light split. Okay, here combined white light split. Okay, combined white light split. This splitting white light through the process of inversion of prism converted into single. Okay, next, see, what is dispersion? What is dispersion? Dispersion, tell me. Dispersion, anybody from the comment section? Disperse, 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 split. Okay, why do different colors of white light bend into different angles? Because of their wavelength and because of their behavior of the lights. Okay, dispersion means splitting, separating. Okay, next, rainbow formation. We all are like rainbow, right? When the rainbow, is it possible in a daily life? If I want to see the rainbow, is it possible? Rainbow, is it possible? No, it is only happen when rainfall is there. Why rainbow formation in presence of rainfall only? Why? Here is the answer to know why rainbow formation in presence of rainfall. Okay, what happened? First, splitting, separation. Splitting is nothing but, remember, split, separated. Okay, separated. Which light is separated? A sunlight enters a raindrops and split. Okay, sunlight is enter a raindrop and splitting into color. Then after, where it is separated? Where it is separated? Where it is separated? In raindrop it is separated. Where it is separated? In where it is separated? In raindrop. In raindrop it is separated into consisting colors. Remember, if splitting means it has to pass to the any transparent material like prism. So here also passing through the raindrop. Raindrop also transparent. So there it takes place splitting. In a raindrop, it splits into colors. After that, if splitting into sub colors, what happened? Reflection takes place. Where in raindrop only, back of the drop, back of the drop, and bounces back. Reflecting means what? Bouncing back only, na? From where it comes and it gets back to the same only. And then after bending, where it takes place bending? When two mediums are required. That means, okay, enter bend again as they leave the drop and travel to our eye. Okay, three things will happen. Splitting, first it will split, then after reflected, then after bend. Okay, splitting, reflection, bending, splitting, reflection, bending, splitting, reflection, bending. See here, single white light, single white light. When it is entered, see, this is the entering point. This is the enter point. When it is enter, what happen? Look at that. Splits, split and strikes the second surface. Second surface. And then after what happen? First split. Then after what happen? Reflection takes place. Whenever it is reflection, what happened? Where it takes place? Inside only. Where it is takes place? Inside. Inside is what? Water is present. And outside is what? Air is present. So light travels in two different meter. Water to air. Then refraction takes place, na? Refraction takes place, na? Very simple, guys. Very simple. Remember that? Split, reflection, bending. When splitting, entering. When reflection takes place, bouncing back. Bending, changes the medium. Water droplet to air. Very simple. Okay. Next, it is the bending of light. It's the bending of light as it passes through the different layers. Now see the atmospheric refraction. We know the refraction, right? Refraction means when light changing from one to another. Here we see in a raindrop. Okay. In raindrop, we see the refraction only, na? Third one is what? Refraction. First one splitting. Second one reflection. Third one refraction. When refraction takes place, tell me. When refraction takes place, basic na refraction. For suppose, if I am taking a glass of water, okay, in a glass material, if I will place a pen like this, how it look like? How it look like? It looks like a bend. Who? Which one? Water or glass? No, it's a bending of a pen. And I have it out and I open the pen again. It will be like this only. But when it is placed in the water, only it is appearing like that. When it is, how it is possible? Why it is like that? Because here you have to understand the point is that when light travel from air to water, two mediums. So two mediums are there, refraction takes. Here what type of refraction is that? Atmospheric refraction. So atmospheric refraction, refraction we know. Refraction we know. What is that refraction? Bending. Simply refraction is nothing but bending. Why bending takes place? Because travels in two mediums. What are the two mediums are there? Atmospheric refraction. In atmosphere, two refractions are there. In atmosphere, two refractions are there. How it is possible in atmosphere, two refractions? How it is possible? If it is taking place refraction means how it will be? Bending. Where takes place? In two mediums. Two mediums is nothing but in atmospheric refraction, only air is present. Na? If surrounding room, what it is present? Air it is present. Okay. In atmospheric refraction, the air density will be different. Air density will be different. So where the density will be maximum? Air density bottom, then the top. Okay. The air at the bottom denser than the air at the top. Okay. Bottom have one density, top have another density. The air density will be changes na. Air density means the molecules will be different, right? Okay, at one place group of molecules are there. At another place molecules are less. Okay, if you are going on a road, where you will go fast? On a highways you will go fast. And street ride you will go fast? No, never. Because the roads are very close. Here also the molecules are very close. It means high denser. Okay, molecules are loosely, low dense. Where that denser will be high? Air at the bottom denser. Air at the bottom denser than air at the top. So at top one density, how the density will be? Low. At the bottom, how the density will be? More density. Because of this difference, more and low, because of this difference, the refraction takes place. Because of this difference, refraction takes place. Why we call this refraction as atmospheric refraction? Because the refraction takes place with the help of air only. That's why it is called atmospheric refraction. Clear? Atmospheric refraction is nothing but, in very simple terms, is that air differences is there. Because of air differences, one place high density, one place low density. If light travel from two different densities of air, then it takes place refraction. That is called atmospheric refraction. Clear? Yeah. Can we go for next one? Next. In atmospheric refraction, with the daily examples, twinkling of stars. Okay? What is that? Twinkling of stars. Twinkling of stars. Stars will twinkle really. Anybody from the comment section? Stars will twinkle really. If stars will twinkle, we treat sun is also a star only. Sun is also star only. Sun is also star only. Na? Sun also star only. Why sun is not twinkle? Hmm? Why sun is, if stars having a property of twinkling, why stars, why sun is not twinkling? Okay, through the atmospheric refraction, what are the daily life examples here? Twinkling of stars and advance sunrise and delay sunset. These two things will happen because of only an atmospheric refraction. Clear? Clear? See, twinkling of stars is an optical illusion. Optical illusion. Okay. There is no stars twinkle. If stars twinkle, sun also come and go, twinkle, right? Okay. So it is caused by only atmospheric refraction. If they ask you why the stars are twinkling, because of only atmospheric refraction. Okay. See where the stars will be in your pocket. Where the stars will be in your pocket, it is present stars, or in my pocket is present the star. It's very far, right? It's very far. So because of that very far, how it will be? It's a point size. If you are seeing me, okay, in a different places, like if I'm staying at one place, okay, I will be appear like one. If I will go 100 meters long, how I will be? It's like a point. So here also how the star will be, it's a very far from the earth's surface. So then it's appear like point size. Okay, it appear like that point size. And if it is very far means density will be different, air density will be different now, because of that bends continuously. Okay, then it is appearing like a flicker. Clear? Clear? Atmospheric refraction is nothing but because of air density. Remember that. Because of density of air. High density, low density. Okay? Next, look at here. Look at where is the actual position. Here it is the actual position. But where it is appearing, this is the apparent position. Why it takes place? Because of atmospheric, because of atmospheric refraction. Clear? Because of atmospheric refraction, the stars appear like twinkling command glow. Okay, see how the refractive index increasing. If you take a top, how it will be less. At the bottom, how the density will be more. Because of whenever it is going from top to bottom, increases. Clear? Clear. Next, advanced sunrise and delay sunset. Advanced sunrise. So sunrise we can see 2 minutes before. Okay. Why? Atmospheric refraction. Delayed sunset. That means sunset is delayed. Why? That is also atmospheric refraction. Okay. Look at here. Look at here. See. Look at that origin position. Okay. This is the actual position. This is the actual position of the sun. But where we will see at this position. Okay. If you draw a one line that we call origin, look, see it. Where the below the origin or above the line. Okay, where is the actual it is present? Actual position is here, but where we can see 2 minutes before only we will see. Okay, 2 minutes before we see. Why? Why? See how the layers will be. The layers are different layers. The air density will be different. Because of this difference in air, refraction takes place. That refraction we call as that atmospheric refraction. Okay. Okay. Next, see, it is a phenomenon which light rays are deflected in various directions. Scattering of light. Next topic is what, ma? Next topic is what, ma? Scattering of light. What is that next topic? Scattering of light. Okay. Scattering of light means, for suppose, whenever the fog is there or whenever the dew is there, have you seen the light? Okay, or if you are walking in a park, sometimes we see a dust particles. There are many dust particles. Through the dust particles, a light is coming like. Okay, what we call that it is? Why it is like happen like that? Why we see that many dust particles in presence of air with the help of light only? Okay, see, it is a phenomenon. What phenomenon? Which light ray? Which light ray deflected in various directions? What happened? The light rays deflected in many directions, various directions. When when strikes the particles like dust particles. For example, if I am going like this, okay, if I strike the bench, I will go this direction. I will go this direction. After striking this one, I will go this direction. Okay, after striking one more, I will go this direction. So how I am going? Even that light particles also will go in various directions. When it is possible, after strikes the particles, okay, like dust particles or water particles or gas particles which are present on the atmosphere. Okay, next, after that what happened? The atoms, that means which are present in the atmosphere, are molecules which exposed to the light absorb the light energy and re-emit in a different directions. Okay, for suppose if I am going, I fell down, I will be sitting here only. No, I will wake and I will go right. So here also light, what happened? Okay, absorbing the light and it emit in the all directions. Okay, see, explain why the stars are twinkle. Why the stars are twinkling? You know, you know why the stars will twinkle? Really stars twinkle or not? If it is not, why it is appearing like that? We have to say. See, the question is not completed. But the planets do not. Stars are twinkling, but the planets are do not. You have to give an answer for that. Stars are twinkling, you know. Okay, stars. Sun is a star, but the planets not. Planets not. Earth. It's not showing the property. Mars not showing the property of twinkling. Why? Why? Guess the answer and write. Okay. Next, why do stars appear higher than their actual position? Why the stars are appear in the actual position? If I'm taking any glass slab, if I'm seeing, okay, if I'm taking a glass slab, or if I'm seeing these letters which are present through the glass slab, what happened? It is appearing like that. It is appearing like that. Rises the letter, right? Or else, see, if any coin on the water, how it will appears? How it appears? The coin is above than the actual position, right? Why it is like that? Okay, why it is like that? Give an answer. Okay. Next, why it is appearing like that? Next, why does sun appear reddish early in the morning? Okay, why sun appears reddish? Why sun appear reddish in early morning? If you see sun in early morning, how it will be? It is very reddish. Okay, sun in the early morning, how it will be? Very reddish. See how it will be reddish. Why it is reddish? You have to see at morning how the color of the sun. Okay, make a note. Make a note. At morning how it will be. At afternoon how it will be. At evening how it will be. Differences are there na. How the sun at morning, how the sun at evening, how the sun at midnight. Differences are there, right? Observe the sun. Okay, if you have a doubt, observe the sun. Morning, wake up, observe the sun and go. Evening, observe the sun, go. And afternoon, observe the sun, go. Okay, so how the sun appears reddish early in the morning. Okay, early morning is wake up at 10, 11. So morning I saw the wind, I saw the sun. Okay, it is reddish, not like that. Early in the morning, evening and afternoon. Compare these three. Okay, why it is appears reddish? It is how it will be to the origin level. How it will be to the origin level. Okay. Next one, Tyndall effect. Next one is Tyndall effect. Okay, Tyndall effect. And why is the sky blue? This is the a regular question in everybody. Okay, really the sky is blue, or it is appearing like that? What is the reason behind of that? Okay, so what is the topic now? Tyndall effect. What is the Tyndall effect? A beam of light. Beam of light is nothing but, beam of light means, see, this is the called beam. Okay, beam nothing but a group. Beam nothing but group of light rays. Beam nothing but group of light rays strikes that small particles. Strikes that small particle, very small particles like dust particles in air, like this, very small particles. After striking with the small particles, what happened? Collider. Okay, small particles in a collider or a finite solution suspension, or a fine suspension. Then the beam becomes visible. Then this beam becomes visible. This property we call is that Tyndall effect. Okay, Tyndall effect. See what happened? A beam of light is coming. A beam of light is coming. What and coming? What happened? Strikes the small particles. It's very small particles. Colloidal. After that, what happened? The colloidal particles will be visible. This is called Tyndall effect. Okay. See here. See here. The solution is not visible. Not visible water. Okay, and look at here. Look at here. Is there any difference? Any difference? Colloidal takes place. Colloidal takes place. So which are colloidal? A light beam is colloidal with the particles which are present in the solution. If you seeing that colloidal solution, that effect we call it is the Tyndall effect. Here we will not see the solution, not visible water. Okay. Next, next. Why is the sky blue? Why is the sky blue? Can you guess why the sky is blue? Why? Why? Okay, look at here, atmospheric particle, mostly which particles are present in atmosphere? This is atmosphere only. What it is present? Maximum oxygen is present, carbon dioxide is present, nitrogen is present. These particles only in atmosphere, right? Is there any other particles are present? Okay, mostly which is present? Highly present oxygen, carbon dioxide and nitrogen. These particles are highly present. Okay, next, coming to the next one, the particles are smaller than the wavelength of visible light. So what is the range of the visible light, ma? We will take 400 nanometer to 750 nanometer, na? This is the wavelength of light. Okay, 400 nanometer, 750 nanometer, it is the range of light. Okay, visible light. So the particles are smaller than that also. Particles are smaller than that visible light also. Okay, the particles are, which particles we taken? We taken oxygen, nitrogen. These particles are very smaller than the wavelength of visible light. Okay, next, short versus long wavelength. So which is having short wavelength, which is having long wavelength? Okay, so long wavelength will means it has to be travel a long distances. Short wavelength means it has to be wavelength is very short. See, which is having very short wavelength in different colors, blue and violet, or blue and wavelength or short wavelength. And which is having more wavelength, red. Remember, red is more wavelength. Okay, blue and violet are, blue and violet are small wavelength. Okay, less wavelength. Okay, red is having more wavelength, blue and violet are less wavelength. Okay, now see, why the sky is blue? Why the sky is blue? Sun rays will come and strikes which are present, ma? These all are what? These all are what? Small particles which are present in surroundings. Small particles. Okay, how the small particles? Less than the wavelength of light. Particles are less than the wavelength of light. After striking, what happened? After striking, what happened? Changes the direction, na? After striking, what happened? See, red color is there, it travel long distance. Okay, orange is there, that is also travel long distance. That means it reaches to the earth surface. And yellow also reaches the earth surface, green also reaches the earth surface, purple is not reaches the earth surface. Okay, violet is not reaching the earth surface, blue is not reaches the earth surface. So which are not reaching the earth surface? Blue and violet are not reaching. Why? Because blue wavelength, blue wavelength, wavelength symbol lambda is small. Okay, blue wavelength is small. So what it will do? Blue collidal with the other particles which are present. Small particles are there in surroundings, it collidal with that all particles and changing a direction. Collidal with the all particles and changing a direction, then it appears like blue. Okay, so why that sky appears blue? Why the sky appears blue? The reason is least wavelength. Okay, because of least wavelength. Okay, which is having least wavelength? Blue is having least wavelength. Which is having more wavelength? Red is having more wavelength. Okay, so because of least wavelength, it scattered more in all the directions. That's why sky appears blue. Okay, okay, yeah. Now see, why does sky appear blue? Now only we discussed why sky appearing blue. Why? Okay, next, why are danger signals red in color? Why are danger signals in red color? Why? If any danger come, first we will use the red light. Can you guess red color why will use mostly in danger signals? Even ambulance also red color. red color signal on. Okay, and even signals also, traffic signals also, we will use red, okay, yellow. We will use this type of colors on. Why we will use this colors of? And mostly in danger signals, we will use red signal, red color we will use. Why we will use red color? Why? Huh? Why sky appears blue? Because because wavelength of blue is less. It's scattered mode in all the direction, colliding with the particles. Okay. And why danger signals we will use red color? Huh? Here the answer is there. Why? 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 Because maximum wavelength of light is red. Okay, the red color wavelength is maximum. Okay, it means it travel long distances. That's why we'll use for red signals, danger signals, red color. Okay, yeah. So once recapitulate everything, introduction. Okay, summary, look at the summary here. Introduction, what is an eye? Okay, so how the eye will be, how capture, okay, and where it takes place, the image, and we discussed that ciliary muscles, okay, and optic nerve, retina. These are total approximately 8 or 9 are there. We will discuss that in a parts of human eye. Okay, based on that they may ask you MCQ questions also. It will help you to MCQ questions also. Okay, next, power of accommodation. Accommodation is nothing but shelter. Okay, remember the keywords: shelter, defects of vision, defects of vision and their corrections, defects of vision and their corrections. We given one key code also. What is that? What are they? Myopia, hypermetropia and presbyopia. HP company at Miapur. HP at Miapur. Refraction, light through a prism. Okay, how the refraction takes place. Okay, if light rays are incident ray and emergent ray, if it is parallel means what we call that it is. Next, dispersion. Dispersion means what, ma? Disperse, split. Okay, dispersion, split. In splitting only we'll discuss about the recombination of light also. Okay, recombination means again we will place one more prism inverted, then it comes combination. Next, atmospheric refraction. Based on the atmospheric refraction, why this color is blue, sun, why the sky appears blue, okay, and why it takes place sunset and sunrise. Okay, next, scattering of light. In scattering of light, why the stars are twinkling, Tyndall effect and all. Okay, this we discussed na. Okay, yeah, if you have any queries you can comment in the chat box. Okay, I hope you all enjoy the section with a great energy. Okay, you understand the topic in better way. If you have any queries you can comment in the comment section. Thank you for attending the section. Thank you all. We will meet with the same energy and same level in the next class. Okay, I hope you all enjoy the class, and thanks for all of you. Thank you all.